It is the same with when we want to understand the climate change impacts on renewable energy. So we study all the events that have occurred in the past, and then we try to look at what might happen in the future, considering the same sort of meteorological conditions that were conducive for those sort of events in the past. So on the left of the slide, you can see the figure where we have projected temperature changes in the future periods, and they are considered as the future climate change scenarios, where we expect a wide range of differences in temperatures. So going from RCP 2.6, that is the lowest emission scenario, where we have a green future, we have renewables included, we have climate policies, and we have mitigation strategies in order to combat the amount of carbon emissions. And then we have the extremely high emission scenario, that is RCP 8.5. And this RCP 8.5 is also called as the business as usual. This is the scenario where you do not have any sort of mitigation strategy. We do not have any renewables included, and we keep on emitting carbon emissions in the same trajectory that we are right now. And this can lead to different scenarios where you have differences in temperatures across the world that spans from 2.6 to at least 5 degrees Celsius for these wide ranges of scenarios. So first, looking at what is going to happen with the future solar resources across Australia. So we have looked at the mean radiation and the radiation pattern in Australia over the historical period. So we see that because of the geographic location of Australia, we have higher amount of solar radiation towards the north, and as we move towards the south of Australia, the amount of radiation decreases. If you look at the figure B and C, these ones show the changes in the solar radiation that is going to happen in the near future and far future periods, considering the high emission scenario RCP 8.5. So we could see that there is going to be an increase in the amount of solar radiation across the eastern regions of Australia, with decreases on the west. But if you look at the figure very carefully, there are small patches or dots across different parts of Australia. These are the regions where the future change is tested with higher confidence, or we have a higher confidence that these changes would be occurring in these parts of the world. Then there are patches or white regions. So these are the regions of low confidence where the different models that we have analyzed for understanding the future climate change do not agree with the direction of change. So these are the regions where you may or may not have a similar sort of future, considering all the different models that we have estimated and evaluated. When considering what is going to happen in the future, and especially when we want to invest on a large-scale solar farm, we want to analyze the resources. This is done by understanding the mean radiation that I showed you in the previous slide, also looking at what is going to happen in the future, considering the different climate change scenarios and different future periods, but also understanding the uncertainty. So we understand uncertainty in the amount of generation by a metric called RCOV, or that is the coefficient of variability. So the regions that are extremely red, or these are the regions with higher variability. So we can see that the regions in the south of Australia, these are the ones where you can expect higher amount of variable generation. So we would say that these regions are not exactly feasible for having new farms, or even if we have new farms up and running in these parts of Australia, we would need other different mitigation strategies in order to enhance and optimize the amount of generation and maintain a stable electricity supply to the grid across all times of the day. There are also some other impacts, like you have financial risks which is very important factor for the investors and the stakeholders whenever they are trying to have a new wind farm or new solar farm. So what we do is we try to identify the regions, like how will climate change affect the choice of future renewable shares, then which are the locations where you would expect the maximum amount of generation, which would be the regions where you would have lower financial risks in terms of higher returns, and if we can identify the regions where we are going to have the variable amount of generation. So basically, if you say that your region is more prone to variability, you need to give a thought once again if it is financially feasible to relocate the new farm, or maybe utilize the existing infrastructure and grid and think about backup options like storage or even overbuilding.